much bandwidth do you need for most of the workloads that your graphics card does? For gaming, it could be anywhere from 8 PCI 3.0 lanes to 16, and then you won't have any sort of performance issues at all. But what about other workloads? Video encoding, 3D rendering, do these even care about how much PCI bandwidth you're using? For example, if I were to take a GPU riser and put a GPU on it that converts times 16 lanes to times 1, what workloads don't care about the PCI size? I was actually looking for this to see if someone had already tested this theory on 3D rendering, and a YouTuber by the name of Zan Rahark, if I'm pronouncing your name wrong, I'm so sorry, I don't mean to. But he did exactly what I'm doing here with a bunch of 1070s and throttling their PCI lane bandwidth and doing Blender renders with them to see if it actually mattered at all. And surprisingly enough, it didn't. I mean, there was like a small percentage of time increase for the renders, but nothing that you would bat an eye at, I would say. It wasn't like going from 10 minutes of a render to 30 minutes. It was like 10 minutes to 10 minutes and like 20 seconds. So I will be replicating the same sort of a test and benchmark. I will be doing 3D rendering, and I will also be doing video encoding on a graphics card that is plugged into a riser and a graphics card that is plugged directly into the motherboard to simulate a times 16 PCI slot versus a times 1 PCI slot. Okay. When it comes to bandwidth testing, I've seen quite a lot of this testing effort being put towards gaming. How much does gaming depend on 8 lanes of PCI 3.0, 6 lanes, 4 lanes? So that has been pretty well researched to the point where I don't think me also researching it will add much more to our knowledge of PCI bandwidth requirements. And I think Zan did a really good job in his video for 3D rendering as well, so I only have a couple benchmarks to kind of corroborate and support what he's found and not go into so much depth past that. However, I've noticed that there is one aspect that hasn't been really researched a whole lot, which is about video encoding. Most GPUs going back pretty far have a video encoder built on them. Intel chips have them, NVIDIA graphics cards have them, AMD graphics cards have them, and that means that all of that information is being fed through the PCI slot. And I was really curious how much of that actually depends on having 16 lanes of bandwidth. I can imagine, let's say, creating a server where I have a motherboard that only holds 4 things and I have 4 bulky graphics cards that I want to serve up as like a video rendering farm, and I'm limited based on the space of where I can put the graphics cards. If these sorts of workloads, such as video encoding, don't really rely on PCI bandwidth, then I know that I can actually stick in 4 graphics cards with some mining risers, and I can create a quad graphics card rendering server. And I actually found some pretty interesting results. But before we get to that, let me go over my rig. In my gaming PC, I have an AMD Ryzen 9 5900X with all cores overclocked to 4.4 gigahertz. I'm using 2 different graphics cards, an MSI GTX 1650 4GB variant and an EVGA 1066 GB variant, both of which support up to PCI 3.0. I'm also using an Asus TUF Gaming X570 motherboard, X570 Plus, 32 gigabytes of Corsair Vengeance RAM, clocked at 36 megahertz. My CPU cooler is a Cyfuma 2, and I'm on Windows 10. The benchmarks I'll be running, first off for video encoding, will be H.264 and H.265 NVENC encoding with 1080p 60, and H.264, H.265 NVENC encoding with 4K 60. If you're not familiar with a lot of these terms, H.264 and H.265 are a particular type of encoding that have certain amounts of compression versus the other, and they're used to encode video files to store on your hard drive. And at the very end, we're going to have some additional 3D rendering benchmarks to corroborate Zan's findings, one from Octane Bench and one from Blender's Open Data Benchmark. So for all the benchmarks that I'm going to show you, I took a graphics card, put it in the first slot, ran the benchmarks, took it out of the first slot, plugged it into the mining riser, into this one, here, and then put this into the motherboard, effectively bottlenecking it to a single PCI lane, and then reran the same tests. First up, we have H.264 encoding on a 10-minute 1080p 60 FPS video. Both the 1650 and 1060, when they're natively in the motherboard, we're able to render those videos in a little over 2 minutes. But when you put them on the mining riser, that render time increased to about a minute more for each card. Similar story for H.265, but actually not as much of an impact. For the same 10-minute 1080p 60 FPS video encoded with NVIDIA's H.265 encoder, the 1650 and 1060 initially were able to render this within a little bit over 3 minutes, and with the riser being plugged into the graphics card, it added about 30 seconds. So overall, this isn't terrible. There is a measurable impact to video encoding when it comes to reducing the PCI bandwidth, but it's actually not terrible. If I were to build a rendering farm that just did 1080p 60 video encoding, I would be okay with having them on mining risers if I could put more graphics cards on my motherboard. 4K is actually quite a bit more of an impact when it comes to restricting the PCI bandwidth. The 1650 and the 1060, rendering a 10-minute 4K 60 video with H.264 NVIDIA encoding, initially did 7 minutes render time. Then when you put them on the mining riser, you can add about 4 minutes or so to both the render times. Quite a bit more than the 1080p video encodings. H.265 is actually a similar story. Same 10-minute 4K 60 video, 1650 and 1060 also see about a little less than a 4-minute bump, but quite a bit, just like before. So this is actually interesting findings. There is some increased render time, but it's not terribly drastic, right? It's not massively longer to encode. It's just a couple more minutes or like half a minute, depending on the video file, depending on your graphics card, all those sorts of things. And this is only with PCI 3.0, which has a fixed bandwidth. When you go to PCI 4.0, PCI 5.0, on the same mining riser, let's say one day if this supports PCI 4.0 and 5, then you might get different results. You may actually not see any sort of bottleneck for doing 4K 60 video encoding when you have a graphics card on a mining riser, which is ridiculous. If you'd like to see the files that I'm using here for these video encoding tests, I'll have a link to those down below. It's to a website called Kodi, which has various 1080p 60, 1080p 30, 4K 60 video renders of different kinds that you can download to do various sorts of tests. And the other benchmarks that I did were around 3D rendering, one with Octane Bench, which is 5 standardized 3D rendering scenes on both the 1650 and 1060. And it's really funny because these results don't make any sense in my brain, but there's a 9% improvement and a 10% improvement when you put the graphics card on the mining riser. I don't know. I might retest it at some point, but it's kind of funny. At least I know there's no negative impact, right? And lastly is Blender's Open Data Benchmark, which is 6 standardized Blender scenes that I went ahead and split the results out into 2 different slides, so it's easy to understand that there is no impact. You can see the BMW, Classroom, Fishy Cat, Koro, Pavilion, and Victor scenes. Don't see any impact other than the test that I ran on Victor on the 1650 just crashed. I don't really know why it would have crashed on the riser, but hey, we're testing stuff here. But anyways, looking at the results, there's not really that much of a render time difference when you're on no riser versus being on a riser, which is right on par with Zan's, which is right on par with Zan's findings. And it's much the same on the 1060 as well, although you do see that there's some variance depending on what the scene is. So the BMW, Classroom, Fishy Cat, Koru, Pavilion, those don't see much of an impact at all. They're kind of the same render times. However, for Victor, there is quite a bit of added render time on the end. So this makes me think that there's a lot of variables here that has to do with whether or not the performance is impacted. Whatever your workload is, if there's actually a lot of back and forth transferring or really large files from the motherboard to the graphics card, maybe like there were in the Victor scene, then you will see an impact on the PCI lanes. But as you can see on the BMW and Classroom and other sorts of scenes, it doesn't really matter. You could put, let's say your motherboard has 6 PCI slots, you could put 6 RTX 3080s in there, and you could render as if you had 6 3080s in the 6 slots without a mining riser, and it'd be the same performance, which is just whack. It's crazy. So now it begs the question, should you go and buy these and then try to get more graphics cards and shove them into your motherboard now that you know that some workloads actually don't care about the PCI bandwidth? Well, maybe. It depends on what you're going to use your computer for. If you're just going to be gaming and streaming to Twitch, get yourself an NVIDIA graphics card. Even 1000 series is perfectly fine for that. You don't need more graphics cards. If you're going to be a 3D artist for a very long time, or you are one, and you have access to buy a couple old gen cards or even buy quite a lot of current gen cards, then yes, you should make use of the knowledge that you have now that you can stick as many graphics cards in your motherboard as can fit with the mining riser as compared to what you were blocked with before. And you now know that pretty much every graphics card that you plug into your motherboard is going to be an impact to your rendering time for 3D renders. Let's say you're a content creator and you use a video editing software that uses your graphics card for encoding. Should you go out and buy more graphics cards and plug them on a mining riser? That really depends on the software you're using. I recommend a video that ePosfox did where he went over how well DaVinci Resolve scales with more than one graphics card as compared to maybe some of Adobe's software tools for video encoding, because that's really what it comes down to. If you're using DaVinci Resolve or another sort of program that scales almost linearly with adding more graphics cards, then yeah, go for it. You're gonna shave your rendering times down to so small. Super important. But if you're using a program that doesn't scale with adding more GPUs, you're not going to really benefit by getting more and sticking them in your motherboard. It's just going to add more hardware and you're not going to get anything. And that is it for the video. I hope you learned a lot from these benchmarks. I really did. It even taught me that I don't need to have a full graphics card to do video encoding and streaming. So as an example, downstairs in my living room, I have an old laptop from 2013 that has an AMD 6700 XT on a riser plugged into that laptop's mini PCI slot where the Wi-Fi card used to be, and I'm doing 4K 120 gaming on that bad boy. So proof of concept that video encoding can still be possible even when your graphics card is bottlenecked. Thanks again for joining. Give me a like if you liked the video, give me a dislike if you didn't like the video, and subscribe to my channel if you'd like to see more of this guy posting random videos about different sorts of topics. Yeah, thanks for joining. I'll see you in the next one.